Good afternoon, everyone. Welcome to the day two orientation session, which is on importance of feature engineering and most used feature engineering tools and techniques for machine learning. Hope all are doing good. I guess I'm audible to everyone who are out there in today's session. So, one check, I'm audible, right? You can just put it in the chat box or you can unmute yourself and tell, yes, I am audible to you all. No response. I think I'm not audible to the participants who are there. Am I audible? Audible, yes. Okay.
Yes, you are.
Okay. Thank you. Thank you so much. Yes, Manoj is also told, yes, I am audible. Fine then. So let us start off with the session, day two of our session. That is on importance of feature engineering. And we have seen those importance of feature engineering on what are the different tools of feature engineering in yesterday's session. So let me just take you all through. Maybe like in yesterday's session, few might have not attended yesterday's session, if you are new to this session today. So for them, I'm just going to take a brush up of 15 minutes of what was done in yesterday's session. Okay, so the agenda which we had covered, which we started yesterday, was what is the machine learning and the feature engineering. We gave a great explanation on what is that, and then what is the importance of feature engineering, like few best tools for feature engineering we had seen. So today we are going to learn the feature engineering techniques like encoding, feature hashing, bucketizing, binning, transformer, normalized, standardized methods, feature costing, what is principal component analysis. So all these things we are going to learn, all the feature engineering techniques we are going to see in today's session. Okay, so a small go through what is feature engineering. So it is a process of selecting, manipulating and transforming the raw data into the features that can be used in supervised machine learning. So in order to make the machine learning work well on new tasks, it is very necessary to design and train it with the better features. So we are extracting the features from the raw data, and we had given it with an example, and we have seen various processes in the feature engineering, that is feature creation, transformation, extraction, EDA and benchmark as well. And we had seen why feature engineering is important, and with the deep learning we had given a kind of a explanation as well. And the best tools for feature engineering, which we had seen yesterday, is the feature tools. So the first feature, instead of this one, let me just take you all through this advantages and the limitations. So these are the feature engineering tools which we had seen yesterday. So that is feature tools, AutoFeat, TS-Fresh, and 1BM. So feature tools, like most popular, it is a most popular tool. It is a good it has a good community support, good at handling the relational databases. And when it comes to the limitations of the feature tools, of the feature engineering, it does not have a support for unstructured data. When my data is unstructured, it doesn't support to extract the features or to do the feature engineering. So it creates a large number of features. Okay, and then we have the AutoFeat. What is AutoFeat? What does AutoFeat feature engineering tool does? It is simpler to understand, easy to use, and good for non-statisticians as well. But one problem with AutoFeat is nothing but it can handle only the single table. When there is a lot of tables together, that is the relational tables I have, then it will not be able to handle. That is, AutoFeat cannot handle. Only a single table it can handle, and it cannot handle missing values. AutoFit tool cannot handle missing values, and it lacks many common and important features as well. And then we have TS-Fresh. So TS Fresh is also a feature engineering tool which is easily integrated with the feature tool. So this is a Python package, one of the Python package. And then it is only good for supervised machine learning. That is a limitations when it comes to TS Fresh. And this one also, it works on only the single table. It cannot work with relational tables. Okay, and open source implementation, yes, it is an open source implementation. Even AutoFit is an open source implementation. Feature tools is also an open source implementation. But when it comes to the 1BM, so it is for both relational and non-relational data are supported here. It generates both simple and complicated features. This is the best one, but it is the best one. But the thing is, it is not an open source implementation. It handles relational databases. Only one drawback with 1BM, which does all the which handles all the relational and non-relational tables, as well as it supports simple and complicated features. But the one main limitation with it is it doesn't have any it is not a open source. That was a one drawback, which limitation which is there when it comes to 1BM tool in for the feature engineering. So these are the tools which we had discussed yesterday, right? So now we are just coming back to the feature engineering techniques. Feature engineering techniques. So when I say feature engineering, it is nothing but it is describing the process of formulating a relevant feature. Okay, it is describing a process of formulating a relevant feature that describes the underlying data science problem. Okay, with that feature, it is going to tell us what is the underlying data science problem. How it is going to say, it is going to say as accurately as possible and make it even possible for the algorithms to understand and learn the patterns, the feature engineering. Okay, learn the patterns. I can put it in other words like this: features you provide, okay, when you are doing the feature engineering, it is going to provide or serve as a way to communicate your own understanding. Okay, your own, your as a human, we have certain understanding on the data, right? So it is going to help us communicate with our own understanding and knowledge about the world to the model which you are creating. So each feature describes a kind of information. Okay, it is a kind of information, we can say it is a piece of information which we are getting from the complete data set. So when I sum up these pieces, when I extract the feature, when I get the features and I sum up these pieces of the features which I have got, it will allow the algorithm which I'm going to create to draw conclusions about the target variables, right? So at the least, what will happen if you have a data set that actually contains the information about your target variables, it is going to help us to sum up the pieces so that I can draw conclusion for the algorithm which I'm been creating. So when it comes to one of the magazine, that is the Forbes, one of the famous magazine, that is Forbes magazine. What happens? What does that magazine says is that like when we had tried to research that, like most of the data scientists spend about 80% of their time collecting and preparing the relevant data, right? And with the data cleaning and data organizing alone itself, that itself will take up to 60% of their time. Okay, when I want to analyze something or model my data, what happens, the cleaning and organizing the data itself will take up to 60% of our time. But this time is also like kind of a well spent only, because only if I give a good data to the machine, it is going to give us a good output as well, right? So whenever it comes to this kind of cleaning and organizing, I always believe that the quality of the data is very important. So as well as the proper preparation of the data set features is also very important. So those two, the quality and the proper preparation of the data set features, is having a greater impact on the success of the machine learning models than any other part of the machine learning pipeline. So if you see this particular picture here, like according to this Forbes magazine, it considers as like cleaning and organizing is usually broken down into like two or three subcategories in the machine learning pipeline. So this data preparation, that is the cleaning process, cleaning and organizing, the yellow color one which has been highlighted in this image, is a cleaning and organizing process which is about the data preparation, what is happening here, right? So here if you see, it has the data processing and wrangling, feature extraction and engineering, feature scaling and selection, which is very very important when it comes here. So this data pre-processing, okay, data processing or data pre-processing, what does that mean? So that is the first of our initial preparation of our data. For example, when I want to do some smoothing a signal or deal with an outliers, so I will be using a data pre-processing step, and then I go for feature engineering. So what is this feature engineering? So as we have discussed a lot more about feature engineering in yesterday's lesson, yesterday's orientation session, here if you can see, defining a kind of a input feature for our model. In this feature, I'm going to define an input feature which I'm going to give to the machine to create a complete model. For example, by converting an signal to a frequency domain using a fast Fourier transform. So I am allowing us to extract the crucial information from the raw signal which I am going to provide it to. So this is a kind of an example like we can give for a feature engineering. And then I have the next one, that is feature selection. So what does the feature selection mean? So in the data preparation, feature selection is nothing but it is the selection of the features that have a significant impact on the target variable what you're looking for. Okay, significant impact on the target variable. So by selecting the important features and by reducing the dimensionality. So we are also, when it comes to feature selection, I'm target variable I'm selecting. Along with selecting the target variable, I'm also reducing the dimensionality. Why reducing the dimensionality is very very important? Because when our data, when we are training our machine learning model, should not be overfitting also, underfitting also. It should be optimum, right? If my dimensionality is big, my data dimensionality is big, what happens? It will be over weight, like my data will be overweight, right? So that's the reason we will have to maintain or reduce the dimensionality. So we can significantly reduce the modeling cost also by reducing the dimensionality, and increase the robustness and the performance of our machine learning models. So this is all coming under the feature engineering techniques. Okay, so data, that is data preparation, like data pre-processing, feature engineering and feature selection, all these comes under cleaning and organizing our data. Now we are going to learn the feature engineering techniques. So what are the feature engineering techniques we are going to learn? We are going to see encoding, feature hashing, binning, bucketizing, or we are also going to see what is feature crossing as well, what is normalization, standardization. So with few examples, we will try to take a look at. First, we are going to see encoding. So as per our yesterday's discussion, what is the main important thing for in the feature engineering is nothing but I want to make the machine understand what we are giving. For example, that we have lots of information in our data, like we might have the categorical information, we might have the dates, time series, these kind of information I will be having. But how will a machine try to understand those categorical information? If I say I'm a bachelor, like I am bachelor's, completed my qualification in bachelor's, or I am completed in post graduation or masters, or I have done my or I have done a kind of a diploma in statistics or economics. So these kind of things are there, the differentiation. So the same thing, how I am going to make the machine understand about these, whatever it is. So a machine readable form, I am going to convert the categorical values to a numerical value so that it becomes a machine readable form. The first one which we are seeing here is encoding. So what does this encoding say? So feature encoding is nothing but it is a process used to transform the categorical data into the numerical values. So if you see the example below here, I have the education which has bachelor's, master's, doctorates, like graduation, 10th pass, 11th pass. So lots will be there. So in that, how will a mission, how I'm going to convert this categorical column into a numerical column, so that numerical column will be understood by the model which we are creating. So that is what our target is. So this feature encoding, we are going to transform the categorical data into a numerical value that can be understood by the machine learning algorithm. So there are several types of encoding, like we have the label encoding, we have one hot encoding. So these are the several types of encodings which we have. The first one which we will be seeing here is label encoding. Okay, the first one which we will be seeing is the label encoding. So when I say label encoding, so that involves, mainly it involves assigning a numeric value to each categorical value. So it is just going to assign a numerical value to each categorical value. For example, bachelor, it is assigning 1, masters, it is assigning 2, doctorate, it is assigning 3. So like this, it is going to assign a numerical value for each of the categorical values. So sometimes what happens, this can be effective if there is an inherent order of the categorical values. So let's say if your column is having a proper order, then this kind of label encoding is a kind, it is good, such as like if I have the grades from A to F. Okay, if I have the grades from A to F, so which can be encoded as a numeric values from 1 to 5 or 1 to 6, that way. So however, if there is no inherent or a proper order, inherent order or a proper order to the categorical values in your column, so what happens, the label encoding may not be the best approach. So then you will have to go to the one hot encoding method. So you have this one hot encoding method. So label encoding cannot be a best approach when there is not a proper order of your categorical data. Then you will have to go for the one hot encoding. So what is this one hot encoding method? In one hot encoding method does, so this one hot encoding, it is an alternative method which will transform the categorical values into the numerical values. It is also going to do the same job, but in one hot encoding, the columns of the categorical values are split into several new columns. What is happening, each the column, the values in the categorical column, for example, in the education column, I have bachelor's, master's and doctorates, right? So these values will be converted to a column, will be created to a column. So this one hot encoding will transform the categorical values into the numerical values. So how it is going to categorize, it is going to split into several new columns. All the categorical values, what is there, it is going to split into several new columns, one for each unique categorical value. Once it is split, for example, I will take the same example like what I had given for label encoding. So let's say I have a categorical value grades from A to F itself, and then we could have the 5 new columns for each grade. Okay, so wherein each row in the data set would have a value of 1 in a column corresponding to its grade of 0 in the another column. For example, if you see here, bachelor, masters and doctorates is being given here. And if you see the bachelors, the first row is going to be in that column, 1 will be there and the rest will be 0 and 0. So certain permutations I'm going to give here. And then zero, masters is there, 0, 1 and 0, and then doctorate 0, 0, 1. And if you go for the next another new value, categorical value is there, and the next row will be just like 0, 0, 0, 1. So like this, it will just give the value. So wherein each row in the data set would have a value of 1 in the column corresponding to the grade of 0 in the all the other columns. Okay, so this, as a result, we call this kind of a method as a sparse matrix. Okay, sparse matrix, and then where most of the values here will be 0. When it comes to one hot encoding, the another disadvantage is over here. What is the another disadvantage? Here it is trying to give us a lot more columns, right? Significantly, it is increasing the size of the data set. What is happening, we have already the big data. From that big data, for each column, when it is tried to create another new columns, what happens, my size of the data set gets increased, so which can be a problem if the column you want to encode contains like hundreds or thousands of the unique categorical values, right? If you have lots of unique categorical values in that particular column, what you're going to do, the convert of the categorical to the numerical, what happens is the columns will become more. So what, for this reason we have another, so that we can reduce the dimensionality. So because of this, dimensionality is increasing because the data set is getting larger and larger, so I can reduce the dimensionality also. So we have certain other kind of way or technique to reduce the dimensionality when we are going with this one hot encoding. So before that, we will just I will just try to show it practically with the data, how this label encoding and one hot encoding is working, what function we are going to use. I'm not going to explain each and everything, then it becomes a complete course here. So I will just give you what functions are being used so that you're going to do the label encoding and one hot encoding method or process over here. So if I just take you all through this, hope you all are able to see the screen. Yes. So feature engineering techniques. So encoding we have started. Here I'm going to take, so in this particular Jupyter, this is a Jupyter notebook, which Python programming language. I'm going to use a Python programming language and show you how this label encoding or the feature engineering is being done. Okay, here I'm going to follow using the pandas, scikit library or TensorFlow library. So like these libraries, so that I can apply the label or one hot encoding for our data set which is there. So the data set example data set what I have taken here is a census income data set. Okay, this is a census income data set. So I have taken this data set. So what the census income data set gives us the information about. So if you see, I have written this one also for you all, because even if I just keep talking, you might skip few things. That's the reason I have given the inputs here, so that you can try to read it and understand. So the census income data set, it describes the income of the individuals in the United States there. Okay, so it includes the age, sex, marital status, and the other demographic information, as well as their annual income. So which is divided into two categories over like $50 or under. This is in the dollars, in the range of the dollars. Okay, $50 or under $50, over $50 or under $50. And for labeling, okay, for labeling example, I will be just taking the education column of the census data set. Of the census data set, I'm just going to target the education column, that is a categorical column. So which describes the highest level of education achieved by the individuals within that population. Okay, so it contains information such as whether the individual has completed his high school, completed his college, earned or a graduate degree or some other kind of education he is related to, all these information. So first I have loaded the data set with the help of pandas. So I will always have to import the pandas as PD, because every time I go, I will have to load the pandas. Uh, you want the data set. So this is a web source. I have downloaded it from the web only. If you are really interested to work with it, I can provide you the data set at the end of the session. Okay, Lily? Yes. So, and this is a pandas data set which is there here. So the census income. So pandas.pdcsv is being given here. That is read CSV. I'm going to read the CSV. The CSV data, this is an adult.csv file, the name of the file. So here, these are the columns. So if I just extract it, when I just want to visualize it, this is how the data looks and the value looks. If you see, the education column is what we are going to look into to extract the features, to do this feature engineering. HS grad is there, some college, 8th, 7th, 8th, some college. So if I want to know the complete details about that particular education column, I have done the value counts. So which means it is going to tell me each and every unique values in that particular column. So in education column, there are like HS grad and some college, bachelor's, master's, associate view, C is there, 11th, ASSO, academy, ACDM, 10th, 7th, 8th, 7th, 8th, professor school, 9th, 12th, doctorate, 5th, 6th, first 10. So these are like, I think 16 value counts are there in this education column. So now with the help of the SkyKit label, I'm going to do the label encoding using the SkyKit learn. So label encoding using SkyKit learn, how will I do it? I will be importing the pre-processing, import the pre-processing from the SkyKit learn package. Okay, from the SkyKit learn library, import the pre-processing, and then when I want to do the label encoding, okay, when I want to do the label encoding, I will have to fit the encoding and I will have to transform or train the label encoder to label the education column. Okay, so first I will have to fit the label encoder. How will I fit the label encoder? By using this pre-processing is the module name, that is the module which is there in the sklearn, and pre-processing dot label encoder function. I'm going to use the label encoder function, and then first I will fit that categorical column. Once I fit the categorical column, I'm going to transform it so that all the numeric values are going to get converted to the all the categorical values are going to get converted to the numeric values. So census underscore income is the data set name which we have provided. A simple function, so it is going to give each and every categorical values with the numerical values. So this is the one education underscore label. This is the one which it has labeled for each categorical value. It has provided directly, it has provided certain numerical values. Okay, so it now the machine will be able to read it. And here also sometimes we were discussing, right, it might not be consistent. What if, for example, if we see the value count here, if you see the categorical values in this particular education column, what is happening? There is no proper order of the education what is being given here, right? There is no proper order of the education which is being given here, so it's just mixed. For example, if they had given from first, second, third, and then completed that 8th, 10th, so if that is there in a proper order, then it is fine. But here the education whatever is there, the data which is being given, the values which is being here is not in a proper order. So label encoding and the values which we have got here might not help to get a proper prediction from the machine learning model. So we have one hot encoding, right? So what does this one hot encoding do? It will split the categorical values into the different columns. So each 16 value is 16 data values are there, right? In that particular education column, all the categorical values have been gone to the column wise. Okay, have been split to the column. First, how the label encoder will be processing that, we will be doing that using the code is I will be using the dummy. I will first get a dummy data sets, get dummies. Okay, if I just try to put dummies, everything will be getting a dummy values. Okay, each and every column will get a dummy values, and then once I go with the dummy values, and then I am going to use the label by binarizer, because we are going to give the 0 and 1, right? One hot encoding is just going to go for 0 and 1. So from the scikit-learn pre-processing, we are just going to fit that particular education column, and then I am going to use this binarizer with this when I fit it, and then if I execute it, that 0 and 1 will be proper. Once that is done, the SK learn pre-processing one hot encoder, I will be using it and I will be getting the output here. Okay, so this is the fit, define and fit with one hot encoder. So this is a one hot encoder. I will just fit it with one hot encoder, and then I will transform the data, that is from the categorical to the numerical value. Okay, I'm not going to explain completely about the codes which is being provided here, because we are also going to see few more other techniques also which is there in our feature engineering. techniques. So what happens when I was trying to tell about this one hot encoding is nothing but there will be a certain problem that is nothing but the dimensionality. Data sets with high dimensionality will be getting created, right? So what happens if high dimensionality is getting created? The memory and the computer power are limited, so it may be necessary to reduce the number of features what is there in that particular data set. So in the data set, to avoid running into the memory or performance issues. Okay, when performance issues or when we want to reduce the memory space and everything, we will have to do it. So how can we reduce the dimensionality to save the memory? So we can go for feature hashing or principal component analysis. Okay, feature hashing or principal component analysis. So what is this feature hashing? Feature hashing is nothing but it is, let me just go to the PPT. Feature hashing, what does the feature hashing do? Feature hashing, mainly we are going to reduce the dimensionality here, because when we are trying to do alternative method, that is one hot encoding, this problem arises, the dimensionality is increasing. So hashing is thus a low memory alternative to one hot encoding and other feature vectorizing methods. So this is another method. So instead of going for one hot encoding and the dimensionality problem should not come, then we go for feature hashing. So this has two steps. Okay, feature hashing has two steps. The step one, what does the step one say? So in the step one, the categorical values are first converted to the hash value using the hash function. So we have a hash function. So with that hash function, it is going to convert it into the hash value. So and then implementation with the help of, we have a scikit-learn library and it uses a 32-bit variant of this more hash 3. We have this particular function for this to do. By using this, we are going to do the feature hashing. Once we are giving a hash value for all the categorical values there, then the next step is nothing but we have a dimensionality by applying, we will reduce the dimensionality by applying a mode function. Okay, so this mode function will calculate the remainder after dividing the hash value by n features, that is nothing but number of features of the output vector. So how many features are there from the output vector? According to that, it is going to divide it and it is going to get the remainder from it. So that will be the value which will be provided to each of the categorical values. So if you see this, the first step, how it is being done. So here, after loading the data set, okay, so this is the data set which is being loaded and each education column is being taken and each count, can you see the frequency, the count is being taken, and then we are going to apply the hash function. So hash function we are defining, this is a user defined function. It is going to return the sklen utils more hash 3 underscore 32 variant. This is a function and according to the row education we are going to ask for. So now if we execute this, each education column, each values in the categorical values in the education column will have a hash value for it, will have a certain hash value for it. Now by keeping this hash value, we are going to convert that hash value to a numerical value. How it will convert? It will convert it with the help of mode function, by applying a mode function to the feature values. So I will be using this mode function. We will be calculating the remainder according to the number of features of the output vector which has been there in that. So n features, if you see, like 8 features output vector, 8 features are there. So according to that, we are going to use this n feature function and then we are going to get the output. So each education column, after the hash value is being given, the hash mode has been applied. So now the values will be like this. So dimensionality problem from one hot encoding is also solved here, and there is no dimensionality problem, and the values, all the categorical values will be converted to the numerical values in a very easy way with the help of feature hashing. First, we will give a hash value, and then we go for converting that step. It has two steps. With the n features, we are going to get the reminder of it, and we are going to do it. Okay, so this a function that is doing just describe steps. Okay, describe steps for us. That is a hash vectorizer function from the scikit-learn. Here we have used this one, this particular function. So instead of this, we can also go and use a hash vectorizer function from the scikit-learn. So feature hashing using scikit-learn. Earlier, which we saw was with the help of pandas, right? With the help of pandas. Now we are doing it with the help of scikit-learn. So in scikit-learn, we have a feature hashing function that is known as hashing vectorizer. So using that also, I can go and do the feature hashing property. So when it comes to Python programming language, there are n lot ways to do the things for the same kind of action. Okay, when I want to get the same action, but there are a lot of methods to end up with that action. So that's up to you how you utilize the things. And then coming to binning and bucketizing, the next feature engineering technique. So the next feature engineering technique which we are going to see is binning and bucketizing. So what is this binning or binding or bucketizing? Is nothing but binding is used for data, both categorical and numerical data. Okay, so it is used for both categorical data also and numerical data also. So we were telling I'm going to give it in a machine readable form. Even numeric values can be read by machine, but that also we will be making it still more clearer for the machines to understand, right? So it can be used for both categorical data and the numerical data. So as the name suggests, the goal is to map the values of the features to the bins which is there here, and replace the original value with the value that represents the bin. So that is what we are going to do here in binning and bucketizing. So if we take the example here, so they have given a small example over here. So for example, they are telling if we had a data set with values ranging from 0 to 100, and we want to group those values into bins of the size 10. So we might create bins for values from 0 to 9, and then 10 to 19, 10 to 29, and so on, right? Till we reach our 100. So I will be having 10 bins. And each from 0 to 100, all the values will be there in that bin. So that is what we are calling it as binning or bucketizing. So in this case, the original values would be replaced with the value that represents the bin. Okay, original values which are there, which will be representing the value which is given with that particular bin to which they belong to, such as 10, 20, 30. So in 1 to 9 values are in the bin of 10, or 10 to 19 values are there in a bin of 20. So such way it will help us to visualize and analyze the data. Okay, so since we are reducing the dimensionality, like reducing the number of unique values in the data set, it can help to prevent overfitting of the data. My data can help in overfitting of the data. It can also increase the robustness of the model, right? When there is no like more of data is there, it will reduce the robustness of the model, and then mitigate the influence of any anomalies which is there or outliers which is there. And it will also help me to reduce the model complexity and reduce the required resources and train the model can also be done. So systematic binning can help the algorithm to detect underlying patterns more easily and efficiently. So it is very like especially helpful if we can already form a hypothesis before we define a bins. So binning can be both for numeric and characters. So bucketizing using pandas. So to bucketize the data by age, so I'm defining 3 buckets. So it's like young will always go for 28 and younger. Middle age will always fall under 29 to 59. And then old age will fall under the bucket will fall, give the age values of 60 and older values will be there. And then The same data, census data which has been there, I'm using it. I'm creating a dictionary. So according to bin which has been there. And plots, I'm going to plot a graph here to check according to the bins which is being given here. So this is the values which we have got, the counts and the age. So in that particular age, according to the bin wise, we have got the graph here. So age and counts, this is 1, this is 2 middle age, 3 old age. So if we see all the data values in the young are like from 28 and younger, like from younger to 28, everybody will fall under the young category. And middle age is nothing but with the age people from 29 and 59 will fall into the middle age category, and old age will fall under the 60 and older falls under the old age category. So now easily I can machine can understand these particular data values, right? So this is how we are doing the binning and bucketizing, by visualizing it, and we are going to look into the features which is there, and now which is making the things also easy for us, right? And the next one is log transform. So what is log transform? So log transform is nothing but it is a logarithm transform, or a log transform we can say it as. It is one of the most commonly used mathematical transformations in feature engineering. So what are the benefits of these log transform? So it helps to handle the skewed data. So we have different types of data. We have left skewed, right skewed. So after the transformation, the distribution becomes more approximate to normal. When I don't have a proper data, when that particular data is not normal distributed, it is skewed distributed, then I will always go for log transform. It is very, very important. When I go for log transform, even we have square root transform also. When I go for log or square root transform, any one I will be able to get a normally distributed data. So that normally distributed data I can use it for my modeling. So in most of the cases, the magnitude or the order of the data changes within the range of the data. So we will just go to this one. I have also explained it over here. So the data you apply for the log transform must have only positive values. That is very much important point which you should remember. Whenever you're going to use a log transform, it should have only the positive value. So otherwise you will receive an error in the data. So all so you can add 1 to your data before the transform it. So in case if you have negative data, you can add 1 to your data, so that you can remove the negative values, and you can do it. So thus you will have to ensure the output of the transformation to be positive. Always you should ensure that output of the transformation should be positive. So this is how you do the log transform. So this is a pandas data frame, created pandas data frame, and then I'm applying a log transform, which is nothing but data log plus 1, and I'm going to transform it with the numpy np.log numpy function. So in case if I have a negative values, so I have a negative values over here, right? In case if there is a negative values, know that the values are different when it comes to the log. Okay, when there is a negative value, the values will be a kind of different here. Okay, so this is log transform, and then the next one is normalize and standardize. So this is a basic thing, most of the researchers try to use it. So whenever they don't have to go for a lot more feature engineering and everything, they try to normalize and standardize the data. So this is simple, right? First, I will try to normalize and standardize the data. So what is this normalize and standardize the data? So normalizing and standardizing data are very important pre-processing steps. So during the pre-processing itself, they will go for this normalizing and standardizing the data. So they can help the algorithm to cover faster and even increase the model accuracy over here. So we can do the normalize and standardized with two methods. One is for the normalizing scikit-learn's minimum maximum scalar. min max scaler is there. So with that, it scales the features to the given range. So it transforms the features by scaling each feature to given range between 0 and 1. So it will not change the value of the data, rather it will just give a value to the data in the range between 0 and 1. And then I have the Skykit learns standard scalar transform data to have the mean of 0 and standard deviation of 1. Okay, so this is normalize and standardize using the Skykit learn. And then the next, the same kind of explanation, if you go and take a look, in case if you are a good programmer, this is how the programming works. So here I'm just trying to explain you all what function you're going to use, minimum maximum scalar and standard scalar. Okay, with this you're going to normalize and standardize the data. So first, always whenever I'm doing any feature engineering, I will try to fit the scalar and then I will try to transform it. So every time it will have a fit transform and then normalizing the data which has been put it in a graphical representation over here. Okay, and after this normalizing and standardizing the data, we have feature crossing. So feature crossing, just a simple explanation, because the feature crossing programs, it takes a lot of steps to do it. The practically, when I want to do feature engineering using feature crossing techniques, it takes a huge lot more time consuming process there. So feature crossing, you should just know about this particular technique. It is a process of connecting multiple features from a data set. So I will be collecting multiple features from a data set to create a new feature. So this can include combining the data from other sources to emphasize the existing correlation. So with that, I'm going to get a correlation. So what happens? There is no limits to creativity, right? So first of all, it makes sense to make known correlation apparent by combining the attributes correctly. So I will just take the known features which is there, I will create a new feature from it. That is known as feature crossing. I will just cross it and correlate it and I will check and I will create a new feature. That is called as feature crossing. And then we have the last one is principal component analysis. It reduces the dimension of the data set. First point, main point is we should not have a overfitting data. So my data should, whenever I'm doing a feature engineering to extract a new feature, it should not end up with increasing my data set. So the main thing, so it reduces the dimension of the data set by creating a set of new features derived from the raw features. Okay, so that's similar to hashing. Principal component analysis works similar to hashing. So we reduce the complexity of the data set and thus the computational effort is required here. So we can also visualize the data with the help of PCA, that is principal component analysis. So the data set with multiple dimension can be visualized in a lower dimensional representation here. Okay, so that the original variation, it will not change the original variation, so that it will preserve as much as the original variations as possible. Okay, that is what the principal component analysis says. It is a bit similar to hashing, which we had tried to see in that Jupyter notebook over there. Okay, so this is the end of the session. Okay, we have come to the end of the different feature learning techniques. So I hope you all have understood